Assalamu alaikum, my dear students. If you remember last time we were discussing about what is the relationship between Kc and Kp. Kc equilibrium constant at concentration C are in terms of molarity, and Kp is equilibrium constant in terms of partial pressure. Now today, if we will discuss some exercise related to that, our equation Kc, relationship between Kp and Kp and Kc. If you remember, if we have Kp, suppose here we have given the exercise for the reaction, this carbon plus carbon dioxide gives twice carbon monoxide. The partial pressure of carbon dioxide is 0.4 atmosphere and the partial pressure of carbon monoxide is 8.0 atmosphere. What is the value of Kp? So when we have to calculate Kp, it is given in terms of gaseous, so we can use the formula Kp is equal to partial pressure of CO square divided by partial pressure of CO2. Now why I didn't use this? Because it is solid, it will not be included in the equilibrium expression, equilibrium constant expression, because solids and liquids generally they are showing unity. So now if I will put the value of this and value of this, what will be the result? So if you see partial pressure of carbon monoxide, it is the partial pressure of CO2 is this and the partial pressure of CO is, so it will be 8.0 square divided by partial pressure of carbon dioxide, it is 4.0. Now if you see, it will be 64 divided by 4, the Kp will be equal to, it will be 16. So simple. This is exercise first. So you have to just use this equation and put the values, you will get the answer. Now in second case we have for the gaseous reaction N2 plus, this is our reaction. Okay, N2 plus 3 times H2, N2 gas plus 3 times H2 gas. It is in equilibrium with twice NH3 gas. And we have given equilibrium pressure of H2. Equilibrium pressure of H2 is H2 and N2. H2 is 0.2 and N2. H2 is, if you see, H2 and N2. So this one will be H2, 0.2 and 0.4 is N2. It is given respectively. The total vapor pressure of the equilibrium system is 3.0 atmosphere. So we have not given this 2 point. This is not given how much it is. But we have given another information, the total vapor pressure. So if we see total vapor pressure of this, it will be equal to, it will be 3.0 total minus 0.4 plus 0.2. It will be equal to 2.4 atmosphere. So we have now this also 2.4 atmosphere. Now you have all values. You have N2, you have H2, you have twice NH3 value. Just apply this equation again because they are all in gaseous state. So we can apply this formula and we can calculate the Kp. Let me solve it here. The Kp will be equal to, so partial pressure of NH3, it is 2 times, divided by partial pressure of N2, okay, into partial pressure of H2, it is 3 times Q. Put the value 2.4 square divided by partial pressure of N2, 0.4, partial pressure of H2, 0.42. So you will find the answer. Now if we have another set of practice problems. In the synthesis of ammonia from N2 and H2, this is the equilibrium reaction. Kc is given here. We have given Kc. So calculate Kp, we have to calculate Kp for this reaction at the same temperature, 300 Kelvin. So here we know the equation is this N2 plus 3 times H2, it will give twice NH3. gas. Okay, so we know the equation. It is Kp is equal to Kc RT to the power delta N. So what is the first step? What you will do? You will calculate first delta N. Delta N for this is 2 minus product minus reactant. 3 plus 1 4. It is minus 2. Now you have this value R. R is gas constant. It is 0.0821 liter atmosphere per mole Kelvin. Now you have this value also, gas constant also. Temperature is given 300 degree centigrade plus 273, it will become 573 Kelvin. So you have Kc, you have R, you have T, you have delta N also. Just to put the values, so if you put the value, Kp will be equal to, and let me Kc 9.6 into RT. What is RT? R 0.0821, okay, into 573 ka whole delta N. Delta N is minus 2. So we will be having value Kp is equal to 9.6. You can divide it 0.0821 into 573. In this way it will become positive. You will get the answer. The answer will be 4.3 10 to the power minus 3. This will be the answer. Now if you have to solve this problem, here it is given for the equilibrium reaction, twice sulfur dioxide gives twice SO2 plus O2. Kc is given also here. So we have given Kc 4.08 10 to the power minus 3 at 500 degree centigrade. So if you see R, it is 0.0821 liter atmosphere per mole Kelvin, and temperature is 500 degree centigrade plus 273, it will become 773 Kelvin. Now calculate delta N. Delta N will be equal to 2 plus 1 3, 3 minus 2, it will become 1. So Kp will be equal to Kc RT to the power 1. So what is the value of Kc? 4.08 10 to the power minus 3 into R 0.0821 into 773 Kelvin. So you will get the answer of Kp. Now before starting another set of exercises related to Kc and Kp, I will give you some shortcuts, some tricks which you have to use in the following exercise. Now for example, shortcuts. Short tricks. Number 1. So these are general tricks which we can use in the preceding problems which we have to do in the next lecture. So suppose if we have A plus B, it is in equilibrium with C plus D. K1 is given. Suppose K1 is X. Suppose I will take it here. It is suppose 70. Now in the problem there is written give the K2 for the reverse reaction. So reverse reaction will be C plus D gives A plus B. Now we have to calculate K2. So how you can give the trick is just to take the reciprocal of this. So K2 will be equal to 1 over 70. This is the answer. Number 1. Number 2. If you have, suppose this is the equilibrium reaction, A gives B, okay, and we have given K1. Suppose whatever it is. Suppose it is X. Okay. Now if in the second reaction anything is added, suppose A n times B, there is stoichiometric coefficient, we are multiplying it by 2 and it will be multiplied throughout the reaction, then K2 will be equal to, suppose X, it is X to the power n. X to the power n. For example, if I will multiply it by 3A, it will be 3B. What will be K2? K2 will be x to the power 3. If I will multiply it by half of A, it is giving half of B. What will be K2? K2 will be x to the power 1 by 2. This is trick number 2. You have to use them in the next lecture in the exercise. So another is, suppose if we have, for example, A, it is giving B. So the equilibrium constant value is K1. Okay. Now we have another reaction, B, it gives C. Equilibrium constant is K2. Now they are giving third reaction. They are saying adding these two reactions, suppose A plus B, C plus A plus B gives, if we add these two reactions, B plus C, what will be K3? What will be K3? You know, after adding this and this will go, so we have A, it is given C. What will be K3? It will be multiplication of these two. It will be K1 into K2. This will be the answer. This is third shortcut which we have to use in the next lecture.